Hi, this is Prashant Jinde. Welcome you all in the next lecture of online series of the subject Basics of Fiber Science. We are about to start a new topic named as natural fibers. In this topic, we try to cover various natural fibers, their cultivation process, morphological structure, physical and chemical properties, cross sections, and usages. Certainly, the list of fibers that we learn includes cotton, jute, wool, silk, coir, and flax. So let's start understanding the natural fibers, starting with a cotton fiber. Cotton fiber is known to the man from prehistorical era. It is one of the oldest fiber, and these fibers actually you can see grown onto the plant. Here is a cotton ball, and fibers are actually placed inside those ball, and when ball bursted out exposes, these fibers are coming out from the ball. Here man is picking these fibers by his own hand. There are various methods for picking, manual as well as machine. So machine can be employed to pick up these cotton balls. These fibers are grown and cultivated in the farms and picked up by the hands or mechanical machines, and then they are transported to a ginning factories. Ginning separates those seeds from a lint material, and now fiber is further processed in the spinning industry, weaving industry, garment, and ultimately a useful product. Chemically, cotton is made from the cellulosic material. Its chemical structure is shown in front of you. Here you can see this is a chemical structure, and cotton is made from entirely of cellulosic material. 95% material present in the cotton fiber is cellulose, and cellulose chemical structure is in front of you over here. Each unit is called as beta glucose unit. Cellulose is a long chain molecule made from a multiple beta glucose unit. Generally, this cotton fiber is cultivated in subtropical region. It needs a humid and hot atmosphere to grow happily. You can see over here, this is a map of India, and green color shows the cultivation area. Now this area is mostly a subtropical area. Over here, atmosphere is humid and hot, and this is a very suitable atmosphere for cotton cultivation. So once fiber is harvested from the farm, it sends to a ginning operation where seeds are separated from the lint. Cotton fibers are then graded according to the length, fineness, trash content, color, and the quality of ginning, which is as shown in this figure. The grades are available. As far as American cotton grading system is concerned, there are 1, 2, 3, 4, 5, 6, 7, 8 grades are available. The good middling is one of the best cotton, whereas the below grade is one of the worst cotton. So prices are according to the grade. So cottons are graded as well. Once we understand the introductory part of a cotton fiber, let's talk about the morphological structure of a cotton fiber. What is morphology? You can see over here, according to the Google, morphology is nothing but it's a branch of a biology which deals with the structural relationship. right? So in simple word, meaning of a morphology is nothing but a study of a biological form related to its structure. In a simple word, the physical composition of a fiber means a morphology, right? So as in this figure you can see, cotton ball is opened up and fibers gets exposed to the atmosphere. This happens in the nature, and but let's understand how this fiber is created inside the ball itself. This is called as a ball, and inside the ball fibers are already created. Now this ball is exposed now, and these fibers are opened up and it is exposed to the atmosphere. But before that, inside the ball, what is happening? So let's understand. uh, let's look at this figure. You can assume this is our ball and it contains a seed, right? In this figure you can see the ball with a single seed, although there are about 200 to 300 seeds present in the single ball. So if you consider this is a single ball, then it contains 200 to 300 seeds, and you can see over here each seed is attached with the fibers. Yes, this is a single seed attached with the fibers. This is single seed attached with the fibers. So here inside the ball there are many seeds present. Let's look at the representative one. That is a single seed. This is a black color single seed. Over the surface of this seed there are many fibers attached. Okay, the fibers are attached to a epidermis of the cotton seed. In biological term, the surface layer of a seed is called as epidermis. So here single fiber is shown and attached to epidermis of this seed. So seed has a surface layer, and over the surface layer a single fiber is attached. Initially single fiber grown as a single cell. Now you can see this is an animated GIF file. You can see initially fiber is a very thin, like here, and as the time passes what will happen, the cellulosic material is deposited layer by layer. This fiber is become thicker and thicker, you can see over here, and this fiber is fully grown inside this ball. When fully grown fiber develops their cell wall completely, then ripened ball opened up and cotton fiber exposed to the atmosphere. Here this figure is shown. When fiber develops completely, the ripened ball gets opened up and fiber exposed to the atmosphere. Due to the dryness in the atmosphere, what will happen? The center part of the cotton collapses and fiber shrinks and convolutions developed. So naturally, the cotton fiber, when it exposed to the dry atmosphere, convolutions are created. What are those convolutions? Let's see and understand in the further slides. But before that, let's understand the morphological structure. Earlier I told you the cotton fiber created by overlapping the multiple layers of cellulose, right? So you can see in this figure, this is a single cotton fiber. It is made from the multiple layers, right? Initially it has a single cell, but as time passes, as these other layers are deposited over that single layer and cotton fiber is created. So there are mainly four distinctive layers. First one is called as cuticle. Over here you can see this is a cuticle, right? This is a cuticle. Cuticle means what? This is a thin layer tightly attached to a primary wall, and it protects a fiber from chemical and mechanical damage. Yes, it protects the fiber from chemical and mechanical damage. It is the outermost part known as cuticle. which is tightly attached to the primary wall. And where is the primary wall? This is the primary wall. The primary wall is built from the cellulosic material, or most of the fiber is built up from cellulosic material, but primary wall is no exception for that. Primary wall also built from the cellulosic material. So cellulosic chains in the primary wall forms a fibrillar structure. You can see the randomly placed molecular chains are there. Those chains are made from the cellulosic material. These bundles of lines are called as fibrils, right? So these fibrils are generally placed at 70 degree to the fiber axis, and the thickness of this layer is around zero point 0.1 to zero point 0.2 micron. Let's talk about the third important layer, and that is called as secondary wall. Now you can see this is the secondary wall, and this is composed of entirely of cellulosic material. It is composed of cellulosic material and contribute most of the fiber weight. That means this secondary wall is the main component of a fiber. It contributes almost all of the fiber weight. Secondary wall is attached to the primary wall, and fibrils in this wall arranged at 30 degree to a fiber axis. You can see this is a particular angle. That angle is 30 degree to the fiber axis. This is the fiber axis. You can see a straight line, and to that straight line, when you draw a 30 degree line, it becomes like this, right? So in the secondary wall, most of the fibrils are aligned at 30 degree. Once we understood about secondary wall, let's talk about the lumen, which is the last part, or you can say the last structure. Lumen is present at the center, exactly at the center of the fiber. It is a cylindrical void, that is empty space. You can now see this is a middle part, and that middle part is completely void, empty, nothing inside in it. The whole fiber is having a hollow portion at the center, right? And that central hollow portion is called as lumen. So ultimately, the morphological structure includes these four layers, which are those: cuticle, primary wall, secondary wall, and lumen. The main function of cuticle is to protect the fiber from physical and mechanical damage, and it is also made from the cellulosic material. And most importantly, the primary wall, which is also built from the cellulosic material and which is tightly attached to a secondary wall, and the fibrillar structure is placed at about 70 degree to the axis of a fiber, and then its thickness is about 0.1 to 0.2 micron. The utmost important layer is the secondary wall. Most of the weight of a fiber is gained from the secondary wall. Secondary wall is composed of completely cellulosic material, and the fibrillar structure is placed at a 30 degree to the fiber axis. And the last part is nothing but the lumen. So lumen is a hollow central part, which is we call it as a void. There's nothing inside in it. Earlier in the developing stage, this lumen sizes are almost about occupies the 35% of the fiber diameter. Now as fiber is built up the cellulose, the lumen starts to shrink and it becomes 5%. So this is all about the morphological structure. Let's talk about the cross section of a cotton fiber. Right. Now this is the cotton fiber, as you all know. What will happen if I cut along the length? The cross section means if fiber is cut perpendicular to the length of the fiber and observe under the microscope. an image will appear. That image is called as cross-sectional area. Now cotton fiber appears, its cross-section appears like kidney shape or bean shape, which is having a middle hollow lumen. You can see this is the cross-section area, right? It is similar like a kidney shape or bean shape, which is having a middle lumen part, right, which is collapsed. You can see this is a mature fiber and this is the cross section of immature fiber. What is the basic difference in between them? What is the lumen? You can see, you can concentrate on the lumen, the central part. The lumen is much bigger comparatively the mature fiber. Immature lumen is much bigger than the mature fiber. Mature fiber having a lot more wall thickness, and wall thickness is made from the cellulosic material. So here cellulosic material is higher in amount compared to immature fiber. Immature fiber shows a very least amount of cellulosic material, right? And most of its cross section is made from the lumen. So this is immature cross section fiber and this is the cross section of a mature fiber. Let's talk about the longitudinal view of fiber. Okay, so similarly, if a fiber observed along the length into the microscope, it becomes a longitudinal section of a fiber. Now you can see this fiber is not looking like this. This is, you can say, a rod like structure, but in reality fiber is not long like a rod. Here the figure shows a correct real image, that is fiber is slightly twisted, or you can say it has certain convolutions, right? So fiber is not a rod like structure, rather it is having a convolutions, it is having a certain twist, and because of this twist or this convolution, fiber gets a property called as cohesivity. So up till now you can understand this is a longitudinal section and these are the cross section. Cotton fiber cross section is look like a bean shape or kidney shape. This is a mature cross section, this is immature cross section fiber. These are the longitudinal sections of the fiber. Cotton fiber has physical and chemical properties. So let's look first all the physical properties. Now in front of you there is a table showing the physical properties, their relative values and the units in which the values are in. So starting with the staple length of a fiber, generally the cotton fiber appears in the length in between 2 to 4 centimeter, right? There are certain cotton varieties available, those are greater than 4 centimeter, but in general we can say the length of a cotton fiber is 2 to 4 centimeter. Similarly, the fiber fineness. Generally, fineness of a fiber is measured in denier or in tex or in microgram per inch. You can say micronair value or sometimes in a micron. So here the fiber fineness, that is cotton fineness, is around 3.5 to 10 micron. You can say in other words its diameter. Next important physical property is fiber density. So fiber density is 1.54 gram per cc. Next is moisture content, which is around 8 to 8.5 percentage based on the weight of a fiber. Now, for example, if you hold 1 kg of fiber in your hand at relative humidity around 65 to 70% relative humidity, then in that case whatever you hold, you feel that this weight is of about fiber's weight, but rather out of 1 kg weight of a fiber, 80 gram weight is of water itself, because the moisture content is about 8 to 8.5 percentage. This is a very important property in terms of financial, or you can say during the purchase of a cotton, right? You pay 1 kg, you pay a rupees for 1 kg cotton, but rather you will get only 920 gram of fibers rather than 1 kg. So what's the remaining? Remaining is water. So you pay for water also. So during the purchasing of a cotton, you must look at this important property that is called as moisture content, 8 to 8.5 percentage. Let's talk about the fiber strength. Generally, fiber strength is measured in terms of tensile strength. Tensile strength is nothing but the longitudinal strength, and it is about 3 to 3.5 gram per tex, right? So this is the unit of a tensile strength, which is around 3 to 3.5 gram per tex. Elongation at break is 5 to 7 percentage. Percentage of what? Percentage of the original length. So if a fiber has a 10 centimeter length, then before breaking, that fiber can extend up to 5% than its original length. And what is the original length? It is 10 centimeter. So extension is 5% of the 10 centimeter, right? It's 0.5. So these are the physical properties. You must understand their values along with their units. So let's talk about the next property, that is a chemical property. Here is the table of chemical properties. You can see these are the chemical properties and their results. Now most of the chemical properties are in terms of action of something on a cotton fiber. Let's start with the first, action of acid. So cold dilute mineral acid does not affect on a cotton fiber. Similarly, the boiling with a dilute acid can produce a hydrocellulose. Hydrocellulose is some kind of a damage to the fiber. When you place a fiber and treat it with the boiling acid, diluted acid, then hydrocellulose form. That means a damage start. And then if a constant if a fiber is placed inside the concentrated H2SO4, fiber completely dissolves. This is one kind of a confirmatory test whether you are using cotton or not. Cotton is completely dissolved in concentrated H2SO4. Next, action of alkali. So normal cold alkali fiber is more resistant to the alkalis. So example of alkali is NaOH, right? So it is quite resistant. Although the strong alkali, what is the effect of strong alkali on the fiber? Fibers swells and forms oxycellulose, right? Oxycellulose is certain kind of damage, but let's see, fiber is not completely dissolved. It is intact and fiber swells also. So as like in case of acid, fiber dissolves completely. In case of alkali, fiber will not dissolve at all, but rather it just swell and forms oxycellulose. So what is the action of water in case? So if a fiber is placed inside the water, what will happen? In the case of cold water, fibers just swells, right? Similarly, in case of action of light means exposure in presence of a sunlight. Fiber is, because of sunlight, carries a UV rays, and because of which fiber starts degrading and form oxycellulose. Oxycellulose or hydrocellulose, these are chemical degradation, you can say, right? So yes, if we place a cotton fiber under the sun for a long exposure time, then in that case fiber start degrading. So up till now we understood all about the physical property and chemical property. Let's look the uses of cotton fiber in various areas. Use of a cotton fabric are making the outfits, outer garments, undergarments, bed sheets, pillow covers, upholstery, curtains, tablecloths, and many more. Right in front of you, there are certain examples. The first one is upholstery, second is a garment, and third one is a home decor, you can say, right? Home textiles, generally curtains, bed sheet, pillow covers, carpets. Most of the items that is generally we use are made from the cotton because cotton is most comfortable one. And in case of a garment also, you can see we want comfortable feel in the hot atmosphere. Generally cotton garments are used, and mostly and 100% we use cotton in case of undergarments.